Matt, thanks for joining us. This is our last vendor session. And yeah, Matt, go ahead, take it away.
Okay, thank you very much, Eric. I'm Matt Garrett. I'm the lead developer for OpenTD, which is the Thermal Desktop API. Today I'm going to talk about, I've called it an OpenTD tour. So we'll talk about some things that are associated with OpenTD and OpenTD itself. Oh, and I don't have my keyboard set up. There we go. Specifically, we will talk about, briefly, I'll go over what is OpenTD. Then we'll talk about the OpenTD Project Hub. That's a place to share your work that uses OpenTD. We'll talk about the Thermal Desktop bonus apps. Those are currently 3 applications that we've developed that use OpenTD and we've made available on the Project Hub. I'll do some tips and tricks, and I'll touch on some of the new features in 6.3. There's a more in-depth presentation on our website of all of the new features in 6.3. So let's dive in. What is OpenTD? Like I said, it's an application programming interface, or API. It lets you write programs that can control Thermal Desktop, and that can be with or without human interaction. Now that now in version 6.3, it's installed with TD 6.0 and above. You can use any language that can talk to the Microsoft.NET framework to work with OpenTD. We recommend and support C#, but plenty of people have used MATLAB, Python, VB.NET, lots of other things. Anything that works with Microsoft.NET. It's strictly version controlled. So what that means is if you write a program for 6.3, then when we release Thermal Desktop 6.4, your program will just continue working the same as it did. You can upgrade to OpenTD 6.4 if you want, and probably you won't have to make many changes to your program, but you don't even have to do that. And we have plenty of OpenTD code from 6.1 that is still running happily in Thermal Desktop 6.3. And it's documented. There's a getting started guide and a class reference document that are installed in your TD directory. And there are a myriad of examples on the CRTech forums, and there are a few videos on the CRTech website. They're more of the overview nature, though. Okay, once you've written a program in OpenTD, what can it do? Well, it can connect to an already running instance of TD or start a new instance of TD. It can connect to one or many instances of Thermal Desktop simultaneously, okay, and maybe trade data between them. New with 6.3, you can create an add-in that runs within TD. So you'll click or your end user will click a button in TD and start your program, okay? Once your program is connected to instances of Thermal Desktop, you can create, query, edit, and delete most Thermal Desktop entities. For example, thermal network elements like nodes and conductors, etc., finite difference surfaces and solids, finite element meshes, all of the FlowCAD objects like lumps and paths, case sets and orbits, the material and optical properties databases, and really, I say much more here, but it's really a lot more. Once you're working with those entities, you can work with units, symbols, and expressions in the same natural way that you would use them in the GUI. Okay, so anywhere that you can use expressions or symbols in the GUI, you can use them in OpenTD as well. Starting with 6.3, actually no, we added it in 6.2 in mid-release. We've added the ability to interact with the GUI, okay, interact with your end user to get an AutoCAD selection set, okay, or you can set the AutoCAD selection set for your user based on whatever criteria. You can run cases and you can control them during the run now. So you can connect to the Cinder run as it's running and interact with it. Once your case is finished, you can explore, compare, and plot results from save files or CSRs using simple OpenTD syntax. And starting in 6.2, I believe, you could also explore the as-solved model topology. Let's talk about the OpenTD Project Hub, which is a place to share your OpenTD projects. So we got thinking about doing something like this after TFAWS last year, because last year I put together a presentation of real-world OpenTD applications. And to get those applications, I really just went to a couple dozen customers of Thermal Desktop that I knew were using OpenTD. And I asked, do you have anything you'd like to share at TFAWS in my presentation? And I was overwhelmed by the response. I think something like 80% or 85% of the people that I went to not only had an interesting application that they wanted to share, but they were allowed to share it. And I was able to put together what was for me a very fulfilling and entertaining presentation. What I really enjoyed was that so many people came up with uses for OpenTD that I hadn't thought of. And that's just a wonderful feeling for somebody who's making tools for other people to use. At the same time, several customers were asking us, is there a place we can post our OpenTD projects? Maybe in the form of binaries or Visual Studio projects or just code snippets, source code, or even success stories, with no code. So we decided, for those two reasons, we thought, let's create the OpenTD Project Hub. All right. We see it as a place to build on each other's knowledge and experience and maybe create new things that are better than the sum of what we're putting into them. So to find the OpenTD Project Hub, it really is just a forum in our forums. So if you go to the CRTech website and you go to our forums, you go to product-specific discussions, OpenTD, you'll find that you can go to the OpenTD Project Hub now. Right now, we've just seeded it with a few things. We've posted a few of the utilities we use internally that we happen to create with OpenTD. But we would love to see your work here as well. Here's a link to the forum as well. Okay, let's talk about those three applications that we've posted to the Project Hub right now. We call them the Thermal Desktop bonus apps, and we've distributed them. If you go to the Project Hub, you'll find that we've distributed them as installers, but you don't have to do that. You can distribute your work however you want, present it however you want on the Project Hub. Anyway, once you get the installers for these three things, you'll find them in the Start menu under Thermal Desktop Bonus Apps. And what are they? Well, there's one called the Dataset Viewer, which lets you just peek quickly into save files or CSRs. There's one called the Template Launcher, which lets you start Thermal Desktop with maybe standard company templates or standard templates, personal templates, and also change some parameters that you might want to change in a drawing file before you start, all collected in one place. I'll show all of these in more detail. And then the final bonus app is called CRTest, and it is a scripting language that we use internally for testing out new versions of TD and Cinda. But I'll show you that in more detail. So let's look at the dataset viewer first. Okay, and the idea here was I wanted, we all run into that situation where we've got a directory with a bunch of non-descriptive names for save files or CSRs. And we're trying to figure out what's what. And we just want to take a quick peek inside. So that's what this is for. You double click on a save file and it shows you the thermal submodels. It lets you know the nodes and conductors for the thermal side. It shows you something similar for the fluid side. It shows you what units it's in, any registers that are in it, UDFAs, and then some information about each record. Okay. I'll just do a quick demo of it. So here I've got a directory with a bunch of poorly named save files, and I'm looking for one that has this model, which has a submodel called sofa. Okay, so I click here and I say, no, this is obviously something small. And I click here, and this is just a steady state run with, again, that small model, it looks like, or a small model, different model, I guess. But and then this one here, oh, this is the one I was looking for. So I can quickly see, and did it have, gee, did it have sofa 20? Oh, yeah, it did. Okay, good. Anyway, so that's the sort of thing you can do with Dataset Viewer. When you use the installer, it associates save files with Dataset Viewer, so you can just double click on them. I can't associate CSR directories with anything, so instead you just drag CSRs onto a shortcut, or you can drag them. So if I had a Dataset Viewer window open, this was that save file, I can just drag a CSR onto that, and it'll show me the inside of the CSR. Okay, I'm going to close that up. Okay, I'll talk about the second bonus app, the TD Template Launcher. Okay, this one was created by Mark Schmidt within CRTech. And as you can see, it gives you a single screen. You know, it's probably just easier if I go right to the program itself. Let's do that. Okay, so it gives us this single screen that allows you to set up things that you often set up when you're just starting on a new drawing, right? You can enter names of new radiation analysis groups, and you can put some layers in and give them colors. And you can put in some submodels, some thermal submodels, and you can I'll just edit flow. Actually, you can edit the fluid submodels as well. You know, even adding fluids from the library. So we'll copy propane in here and call it P in flow. Okay, you can set the units. Maybe we want to be in inches. And we could save this. Actually, you know what? I got ahead of myself. We can save these configurations and reload them. So I'm just going to load this one called blank because it's got some information over here that's useful. So it's got the file name that I want to use, the directory that I want to work in. It could copy a base drawing. We can point to property databases, or we can copy them to the new folder and then point to the copied location. And then here, I'll just add a layer just to prove that it will do that. And maybe I'll edit the fluid submodel too. Just like so. And then we can say, let's bring up that support directory too, just so we can see what's happening in there. Okay, so now I'll open drawing. And you can see it copied those property databases from whatever location that we asked for. And then it'll make sure that the new drawing is pointing to these locations. And what did I add? Did I add a layer? Yeah, so I added a layer called wall, color 10, and I added propane to flow. So let's make sure that worked. So it did. And I borrowed these configurations from Mark Schmidt, and because he does a lot of work in support, he's got configurations that start with the some of the TD template files and let him edit them. Okay, let's close this up and go back to here. Whoops. Okay, and the last bonus app I wanted to talk about is called CRTest. So internally, we've been using this for a couple of release cycles now. Our quality assurance group uses it to perform acceptance testing of new versions of Thermal Desktop and Syndafluent. Like I said, it's a scripting language for doing some kind of focused activities with model files. So it'll open and close drawings. It'll run cases. It'll run just Syndafluent input files. It'll compare results, and then it's got some commands for manipulating files and directories, because that's really handy when you're doing tests. And then you can just call operating system commands as well from it. So it's very much a subset of OpenTD, but it uses this imperative syntax that is familiar to many engineers who don't know object-oriented programming, who might not be comfortable using OpenTD. Again, this kind of shows what it looks like, but it's easier just to show you a demo of it. So it's associated with CRS files, CRTest script files. So we'll load one of those. And I'll walk through this file quickly, and then we'll run it just so you can get an idea of the sorts of activities one might do with CRTest. So it lets you do comments. Blank lines are okay. I'm calling set name and giving my script a name. That'll just be used in the output. I'm calling delete file. That's one of our file manipulation commands. I'm deleting my output file. This is the output file from the script. It doesn't have to have the extension out. It can be anything. And then I'm setting the output to that file. Okay, so I delete the old one and I set output to a new file named that. Until you call set output, it's going to output to the console as it works. Okay, you can define keywords to use later in the script. So I'm defining thermal model 1 to be this path. And then I'm calling open model, thermal model 1. And I add this keyword called will succeed. All right. And you can add this keyword to any line. And what it does is it says, I'm asserting that this operation will succeed. And the interpreter, when this is running, the interpreter is going to keep track of those and give us a summary of how many of our assertions were correct and not. And if any are failed, then the whole script is failed. Okay, it'll continue running, but well, it'll do its best to continue running, but it'll be considered failed. Okay, because these scripts can be run in a batch mode, and the return values indicate whether the whole thing succeeded or failed. All right, so then we're going to call run case, and we have a case called beta 0 in this model, and we are asserting that it will succeed. And then once we get that case, we're going to call compare results against some baseline values for beta 0. And we're going to say we just want to compare temperature values and registers. Actually, registers are kind of implied here. So we're going to compare temperature values and registers, and we're going to compare everything to a 5% tolerance, okay, on like absolute temperatures. And that will succeed, meaning it will match. And then we're going to call compare results again against this baseline. This is just really, this is as an example. We're going to compare temperatures again, and we're going to call it at 0.3% tolerance, and we're going to say that won't succeed. Okay, just because of we're not firing very many rays in this model, so we don't expect that to match our baseline results. And we're adding the no registers keyword to say we're also not going to compare registers. Okay, when we call compare results and we compare these two guys, these two save files, it's going to go through and do all kinds of comparisons. Okay, it's going to look at the submodel names, the names of all the entities in the model. It's going to look at all the temperatures in the model in the results, et cetera, et cetera. When it does the temperatures, in this case, and if any exceed the tolerance, if the difference between the temperature of node main 1 and node main 1 in these two guys, if they exceed the tolerance, then it's going to keep track of that. And you can call this command plot exceedances, and it'll create a plot that looks like this that shows the temperature traces for those two save files and draws a little red line in here to show you where that exceedance was greatest. Okay, the 3 here says show me the top 3, show me the worst 3 exceedances. Okay, there's also a save exceedance plots command. It's just going to, instead of plotting them to the screen, it's going to save them to the directory using this prefix on all of the file names. Okay, then we're calling run Cinda. we're running a Cinda input file, and we are asserting that that will succeed. And we're calling compare results on that against some baseline results and asserting that will succeed. We're calling print message just to print a message to the output. We're calling system command and just looking at the directory listing. And then we're calling open output, which just says try to, using whatever associated program, open whatever file is the output currently. And you could have called set output multiple times here and move the output around if you had multiple sections of this script. We have pretty elaborate scripts really in the quality assurance group. Okay, so I'm going to call save and run, and we'll see if this goes. So it tells us what it's doing down here. It's trying to open the model. And you can see up here in the console, it output to here, and then it said attempting to switch output to the output file. And then the remaining output is in that file, presumably. So now it's running the case, beta 0. Okay, it compared it twice. The second comparison had exceedances because we had that unreasonably tight tolerance. And then at the end here, it's opening the output file for us, okay, because we asked it to. And output files are kind of interesting to look at the very end first, where you get a test summary. It says, well, I found 6 assertions and 6 were true. So the test was a success. You can see here that directory output that we'd asked for. But let's take a look at one of the comparison results because it's kind of interesting. So let's look at the one that failed. So assertion 4 was compare results, baseline against the new results, 0.3% tolerance, will not succeed, right? And it says, okay, same number of records, that's good. The times are all fine, they're the same. Same thermal submodels, same IDs, etc. But the temperatures were different, okay? And the worst offenders were main 72, 22, and 44. So if we go and look at the exceedance plots that were created, we'll see, yeah. Oh, did I say 72? I think I did. I hope so. Yeah, 72 was the worst one. Okay, so we see 72 is the worst offender, and we can see the results from the 2 save files, and we can quickly see where they differ. Okay. That is CRTest, and that's available to you right now on the OpenTD Project Hub. Oops, I've jumped to the end. Okay, let's talk about some OpenTD tips and tricks. So, as I've mentioned, we recommend and support using C# for development in OpenTD. And that usually means that you're going to write code and compile it and then run your executable. But there is actually a C# interactive compiler, which feels like an interpreter, or is an interpreter, in Visual Studio. Okay, you can get to it under View, Other Windows, C# Interactive. And once you get there, it almost behaves exactly like normal C# code. Okay, the one command you need to know that's a little different is this #R. #R lets you load a reference. Okay, so I'm loading a reference to my OpenTD v63 DLL that is in the global assembly cache, okay, the GAC. So once I load that, then it is, as I said here, business as usual, and you can just use OpenTD commands in an interactive environment. So what I've done here is I've created a new thermal desktop object. I've called connect. When I called connect, I saw the AutoCAD window appear. And then I called create disk and zoom extents, and we have a disk that we've zoomed in on. So this can be handy when you want to just do things interactively. In a similar vein, you can use PowerShell to run OpenTD interactively. And the benefit here is that PowerShell is free. One problem is the syntax is a little bit tricky. But here I've done the equivalent operations that we saw in the last demo. We've created a new object of type OpenTD v63 thermal desktop, and then we call connect on it. I guess it's not that different. Okay, so you can use PowerShell. Okay, for the next set of tips, I wanted to talk about BaseTrans and LocalTrans, because these are frequently misunderstood. Well, BaseTrans is frequently misunderstood in OpenTD. So you're probably aware that these are two members that are used to position geometry. Okay, BaseTrans is of class matrix 3D, and it's equivalent to moving stuff around using the AutoCAD commands like move or rotate 3D, that kind of thing. And LocalTrans is a class called transformation, and that's equivalent to positioning stuff using the transrot tab in the GUI. Okay? And the way OpenTD positions stuff that you send to Thermal Desktop is it positions the entities at the world coordinate system origin, then it transforms them by whatever matrix you have in BaseTrans, then it does the transformations in LocalTrans. Okay? Keep clicking on that. So let's look at using LocalTrans first, because it's the easier one. So LocalTrans rotations are intrinsic. So each time you do a rotation, it's about the current axes of the object. It's not about some fixed axes. All right. So in our example, we're going to translate 2 meters along the y-axis. Then we're going to rotate negative 30 degrees about the y-axis. And then we're going to rotate 45 degrees about the current x-axis. Okay, and it's really straightforward in OpenTD. We've got an entity called A. We just set ty to 2. We set axis 1 to 1, meaning it's the y-axis. We set rot 1 to negative 30, and so on for x, and then we call update on the object. Okay, so really straightforward. A little less straightforward is using BaseTrans. So remember, this is the one that is equivalent to moving stuff around in the AutoCAD window. All right. And the thing that happens a lot, well, there's so this just, like I said, this just represents a matrix 3D. Okay, so a matrix that represents some sort of geometric transformation in this submatrix and a translation in this submatrix. Okay. There are a bunch of methods called like set to rot x, set to rot y, etc. And those are frequently misunderstood. What they do, if I say set to rot x 30, okay, then that's going to take a fixed x-axis and create a rotation matrix that rotates 30 degrees around that fixed axis. If I then call set to rot y, it's going to delete what I had before. It goes away completely, and it's going to create a new rotation matrix that's about the fixed y-axis. Okay, each cancels the last operation. So if you want to chain these together, if you want to chain a bunch of rotations, you've just got to use matrix multiplication instead. Okay, so in our example, I'm going to do intrinsic rotations, so about the object's current axes. So let's do a 10-degree rotation about the z-axis, then a 2-meter translation along the current x-axis, then a 50-degree rotation about the current x-axis. Okay, so I'm going to create matrix A, set to rot z 10. Okay, so that's the first transformation. Then I'm creating matrix T, which represents my translation of 2 along the x-axis. And then I'm creating matrix B, that is set to rot x about the for 50 degrees. Okay, and then I multiply them together. I set BaseTrans to their product, and I multiply them left to right because I'm doing intrinsic rotations. Okay, and then I call update. Okay, next tip is about connections and domains. All right, connections. Connection is a class in OpenTD that represents some sort of connection to a physical object, okay? Not a physical object, to an entity in Thermal Desktop. And it consists of a handle, which is a string, and a marker, which is an integer. The handle identifies the entity that you're going to. I'm sure you're familiar with handles if you've been using OpenTD for any length of time. And then the marker identifies how the entity is connected. Okay, it's an integer that represents how the entity is connected. So for example, if we look at the marker values for a finite difference brick, if we look at the decimal values of the marker, it doesn't make a lot of sense. A value of 1 will connect to xmin. A value of 42 will connect to zmax, ymax, and xmax. A value of 63 will connect to all sides. Now, I've kind of given away the punchline by having this column here, but it makes a lot more sense when you look at the number in binary, okay? And you can see that each place in a 6-digit binary number represents off or on for one of these surfaces. Now, there's a special case. If marker is set to -999, then the handle, well, then the connection itself refers to a domain, okay? And the handle string, instead of being a handle, it's the domain name. Okay, so it's a little bit of a wonky thing to do with connection, but I hope you can see why we would do that. It allows us to sneak domains into anywhere that you can use connections. So that's why we did it. Let's look at an example. So in this example, I'm going to apply a heat load to xmin and ymin of a brick. So I'm going to create a brick. I'm going to create a heat load and apply it to the brick. I'm going to say that the applied type is surface. And then I'm going to work with, there's a list called apply connections. All right. And so I know that there's a one element in this list because I have one entity here. And I'm going to change its marker to 000101. Okay, so it's going to be on xmin. Wait a second. Did I do this wrong? Oh, no, I didn't do it wrong. It's on xmin and ymin, okay, because this is xmax. I'm changing its name, and then I'm calling update. All right. As another example, so instead of applying directly to xmin and ymin on a brick, let's apply a heat load to a domain. Okay, so I'm actually going to create the domain first. So let's say I've got a list of connections, all right, called domain connections, and I'm using some criteria to add some connections to that list, all right? And then I call get domain manager, create domain, and I give the domain a name. I say it's a node set, and I'm going to use those connections for this domain, this nodal domain. And then I'm creating a heat load, but I'm sending it kind of a special connection. I'm saying, here's a new connection for you. And the handle, but it's not really a handle, is heated, the name of the domain. And the marker is that special value, -999. And so then I call update on that. And if you were to double click in the GUI on this resultant heat load, you'd find that it's applied to the domain, not to a bunch of nodes. This next tip, it's more of a C# tip or a .NET tip than strictly an OpenTD tip, but it's something that I do a lot of internally in OpenTD and other places, and I just thought if you didn't know about it, you might enjoy it. So the tip is to use the select method or Linq query syntax to transform lists. What do I mean by that? Well, let's say you wanted to get a list of node handles from a model. You might do something like this. You'd create a new variable called nodes, and you call get nodes. You'd create a new variable called node handles, which is a list of strings. And then for each node or each n in nodes, you'd add n handle. Okay, you might do something like that. Using select, it can be a little cleaner to look at. So using select, I'm going to transform the list kind of in place. So I'm creating my node handles, I'm calling get nodes, and then I'm saying, but I only want to select certain stuff out of the nodes to go in my list. Okay, so for each node in this list that you're getting out of get nodes, for each node, I want you to return node handle, and I want you to use that to make this list. So these two things are basically equivalent. But there's actually a bunch of query language methods that you can use here, and Microsoft calls this, I think, Linq method syntax when you do it like this. They also have something called Linq query syntax, and I find when I'm doing a more complicated query, it's a lot easier to read with query syntax. So, for example, what if I wanted a bunch of nodes I wanted a bunch of node handles for just I'm calling it the right side of my model. Okay, so for all the nodes that are at an x value greater than something called x mid. All right, so I just say make a new variable, and then from each node in TD get nodes, where this is true, I want to order it by ascending x value. And what do I want in this list? I want n handle. So select, it's the same thing as select up here. Anyway, I do this stuff we do this stuff all over the place, and it's just so clean to read later. So I thought I'd show it as a tip. And then this last one is another one that we frequently see done incorrectly. And I feel like it's a failing on my part that I haven't made OpenTD work in the way that people are trying to use it. But I haven't been able to do that yet. And so I just try to mention this as much as I can. And that is, when you're making a program that references OpenTD, you need to use the thing called .NET Framework. You can't use .NET Core, and you can't use .NET Standard. They don't have all of the libraries that OpenTD uses, unfortunately. So that means when you're in Visual Studio and you're making a new OpenTD project, you want to make sure that the template looks something like this. You know, it says .NET Framework in it. Windows Forms app, .NET Framework, Console app, .NET Framework, etc. If you can't find those templates in your version of Visual Studio, then you might want to click here, Install More Tools and Features, and then hopefully you'll find this grouping here called .NET Desktop Development. And you'll see it does include .NET Framework. And then you should see these templates. Okay, I'll talk about some selected new features in 6.3, some stuff that I think is pretty cool in 6.3. So the biggest new item, I think, is add-ins. Traditional OpenTD programs run inter-process and connect using inter-process communication to instances of Thermal Desktop. Using the new add-in commands in 6.3, you can create basically buttons and AutoCAD commands that can be run by your end users to run OpenTD programs. And when they run, they'll receive a special instance of the thermal desktop object that represents the thermal desktop that they were opened in, the instance they were opened in. But otherwise, they can do everything. They can do everything any other OpenTD program can do, including opening other drawings or reading results or whatever you want to do. And they use the exact same syntax as other OpenTD programs. All right. Oh, there's a good forum post on how to create them. Because we added add-ins to 6.3, we also added a bunch of new features for working with end users. And most of the vast majority of these new features you can use in any OpenTD program. It doesn't have to be an add-in, but they're especially useful for add-ins. So you can get, set, or clear the AutoCAD selection. You can prompt users to select some nodes or lumps or whatever. You can control the progress bar that you may have seen, I'm sure you've all seen, when you're running like a RADCAD job or something. So you can do that for your long calculations. You can use this object that allows your end users to hit escape to stop your long calculations. This actually only works in add-ins. It only works in process. It doesn't work inter-process. It's the only thing that only works in add-ins. You can get and set the user coordinate system. Now, this doesn't change how things are positioned using OpenTD. It's still always relative to the WCS, but it's something that you can do maybe for your users. You can show and hide the model browser. You can enable and disable undo, and you can get an object that represents the thermal desktop main window, which can be useful. It's especially useful for add-ins so that you can use it as an owner for your add-in dialogues, and then they behave nicely when AutoCAD closes. Okay, internally, Thermal Desktop uses a very flexible logging system, okay, to write to log files. And it's now available to OpenTD authors in the logging namespace. So I'll just sort of show you how it works. Like I said, it's very flexible. So it allows you at runtime to just modify an XML file to change how log messages are routed. So it seems a little complicated when you first look at it, but it ends up being just a godsend for debugging on a user's machine, on an end user's machine. So here's how you use it. You'll create let's say you've got a class called myClass in a library called myLibrary, okay? Somewhere in your class, you're going to define a logger. I've called it log. And I'm going to give it a name, and I'm going to call it myLibrary myClass, okay, type of myClass. So myLibrary.myClass is what I'm going to call it. And that's a good convention to use. Just name it the name of the class. Okay, then somewhere in the class, I can call, there's a bunch of methods, log warn, log error, log information, that kind of thing, that let you send a message from that logger. So somewhere in my class, I'm saying this operation didn't complete, and it's a warning. Okay. Then at runtime, there's this config file that gets loaded, and it's going to determine whether this message gets written to a file or not. Okay. It's going to say, oh, what's it coming from? It's coming from myLibrary.myClass. Oh yeah, okay, I can route those messages. What kind of message is it? Oh, it's a warning? Yeah, I do warnings and errors. So go for it. Send it on to the file. If it didn't recognize it, nothing would happen. Or there's like a default that it might end up in some default log somewhere called the root logger. Okay, I don't think I can have my mouse in there. Oh, maybe I'll just change. No, that doesn't work. Nope. Okay, well, we'll just deal with it. Okay, so let's say it writes to the, let's say it does write the message to the log file. You'll see a bunch of useful information. You'll see the date and a timestamp. You'll see information about the thread that wrote the warning, the process number that wrote the warning, the message, what kind of message it is. It's a warning in this case. Who sent it? myLibrary.myClass. And then finally, what is the message? Okay. In 6.2, we introduced the co-solver namespace in OpenTD. And for the first time, you were able to connect to a running, I shouldn't say for the first time. We had other ways to do it in the past. But for the first time in OpenTD, you could connect to a running Syndifluent model and manipulate it. Now, the way it worked in 6.2, you could open a drawing and run a thermal desktop case and then connect to the resultant Syndifluent run. That's all it could do. That's the only way it could be used. For 6.3, we broke it up a little bit. We broke up that functionality into more classes. So there's now something called an SF launcher that can just run Syndifluent models directly from the IMP file. And then there's something called an SF co-solver that, again, runs IMP files, but then connects to them and lets you control them. You're probably aware that there used to be an API to Thermal Desktop that used the COM interface, and it was quite a bit more limited than OpenTD. But for completeness, I've always wanted to wrap it in OpenTD so that I could say for sure OpenTD does everything and more that the old interface did. Okay, so for 6.3, we've added the command to the thermal desktop object called send legacy command, and it just accepts a string which is the same string that you used to pass to that COM interface. And the Getting Started guide contains a full list of all the strings available and a description of how to use them. Just for completeness, I've added a list of all the new features. There's a link at the bottom of this that takes you to a video that we did that talks about more of the new features in more detail. And then this is just a slide on how to get started with OpenTD. If you haven't used it before and you'd like to get started, this will get you going. I guess I'm ready for questions.
Yeah, great job. Thank you, Matt. You really know your stuff. A lot of that
Thank
stuff
you very
was
much.
a lot of the stuff was over my head, but it motivates me to really dig in. That add-in features, it looks fascinating and very potentially very useful. That's one thing I noticed.
Yeah, thank
So,
you. We'd be happy to help learning OpenTD. Just
okay, well, thank you.
yeah, contact us at support@crtech.com, and we'd be happy to help you.
Okay. All right. So if anybody has any questions, please feel free to type them in the chat. Well,
Hey.
yeah,
Yeah,
I think maybe it might have been over a lot of people's head. You know what, Matt? So I've never used OpenTD, and could you give me like kind of a beginner's summary of what exactly it is?
Yeah, sure. So it lets you write a program, and you can write that program in a bunch of languages, but we recommend C#, as I've mentioned. So you write a program, and then that program interfaces with Thermal Desktop or Syndifluent or save files or CSRs, and allows you to automate tasks that you previously had to do manually. And so those example programs that I showed are really pretty good examples of the sorts of things you can do, right? You saw with CRTest, actually, let's look at the CRTest slide. So you saw with CRTest, this is the program here that I created using OpenTD, and it read some file. Okay, that's just the nature of this particular program. It read this file, and then it used OpenTD to open a drawing, to run a case, to then look at the results and compare the results to something else. These are typical tasks that people use OpenTD for. And it's been around for a few years now. I don't remember when we first released 6.0, but certainly a few years ago now. Oh, looks like Hume's got a question. So does the post-processing data mapper object allow a user to go down as deep as the GUI to display selected groups on a FEM or domain tag sets from the group association subform? It should, Hume. I haven't tested that specifically, but the nature of how I create these new objects in OpenTD is that I do try to follow every path in the, not in the GUI, but in the underlying objects that are represented in the GUI. I try to follow every path as deep as I can, or as deep as I need to. So are you finding that it doesn't seem to, or have you just not used it yet? Or we could talk about this offline too. You haven't tried it yet. Okay. So I'm going to assume it does, but let me know if it doesn't, and we'll fix it.
Matt, there's an engineer in the group, Heston. I think he's still on the line here, but he's doing an analysis where he's optimizing the a quark model, and so what he's doing is he's working on trying to figure out a way to do an iteration to go in and change variables within the quark model to characterize and anchor the quark model on Thermal Desktop with measured data. And
cool.
Can this tool do that? Would it be helpful?
Yeah, it can be, absolutely. So there are some classic methods for doing optimization in Thermal Desktop. And when you find that they aren't providing access to the levers you want to pull, to the dials you want to turn, then it's time to look at OpenTD. And absolutely, an OpenTD program can be on the outside of some sort of optimization loop with thermal desktop, Cinda, save files, etc., on the inside of that loop. And
Yep,
that's been done. There's been plenty of that done by other users.
Yep. Yeah, I'm actually working with Doug now. I think it should be able to do what I need it to do. It's just some of the temperature dependent heat arrays. It it might be how I'm setting it up wrong, but if it comes down to it, yeah, I think this is already kind of one of those cards in my hand that we might have to crack into. But it looks like we should be able to get around anything with this if it comes down to it. So yeah.
Correct. That is the idea. But yes, definitely easier and probably faster to run if you can, use the legacy methods. I shouldn't call them legacy. Use the classic methods. Oh, I should point out that if you were to use this on the outside of an optimization loop, then you'd have to roll your own optimization algorithms. So that's definitely a plus for using the classic methods, right? We've already created the optimization methods
Yeah, like
algorithms.
the BFGS, like so all of that we wouldn't be able to use from the API structure.
Yeah,
Right?
I mean, I hate saying you can't do it because smart users have figured out how to do a bunch of things that I said you couldn't do. So, but yeah, I don't immediately see how to do that.
Okay, that's good to keep in mind.
If you're turning a knob that the optimizer doesn't normally have access to, then I'm not sure how to do it.
Okay. Yeah.
But there might be a way with registers or something. It doesn't look like there are any other questions. So like Doug said, if some questions come to you afterwards, please do write to support@crtech.com, and we will be happy to answer your OpenTD questions.